And then we have 2e. Okay, 2e is interesting. I'm just going to start with the balancing, sorry, the oxidation numbers first. So -2, +6, +1, -2, +6, +2, and 0. So lead is going to be your reducing agent. There is an increase in its oxidation number, and the oxidizing agent is hydrogen in H2SO4. H in H2SO4 is the oxidizing agent. Okay, so H2SO4 is also a strong acid. This is another case of a covalent molecule that could be split into ions, and it is purely because it is a strong acid and fully ionizes. So H2SO4 we can write as 2H plus and SO4 2 minus, 2H plus and SO4 2 minus. However, lead sulfate, even though it is an ionic compound, you can't actually split it into smaller parts because it's insoluble. So it exists as a lattice and cannot be split. Cannot split. All right. Which makes it quite interesting when you have to balance it. So I'm going to start with oxidation. This is something that it's not going to work with cohesive. You really just have to use observation. Pb going to PbSO4. I need to balance the SO4. And if you look at the reactant side, you definitely have SO4 ions present. And I'm just going to add SO4 2 minus here. Cohes is not going to work because cohes is not going to make the sulfur appear. So you are allowed to do this because you can split sulfuric acid into H plus and SO4 2 minus. And this also means that my charge is now imbalanced, so I need to add 2 electrons on here. So that's solid, that's aqueous, that's solid. For the reduction is actually fairly straightforward because I could just use H plus. So H plus going to H2, we're going to use 2 here, and then we're going to have 2 electrons. So that's that for part E.